Hello everyone, this is the Google CodeJam 2021 qualification round, the first and the third problems together, Reversort and Reversort Engineering. The description for both problems are the same. Reversort is an algorithm to sort a list of distinct integers in increasing order. The algorithm is based on the reverse operation. Each application of this operation reverses the order of some contiguous part of the list. This is the pseudocode. Loop from the first to the second last position. Reverse the sublist from the current position to the mean value position until the end. The cost of each iteration is simply the length of the sublist passed to reverse. The cost of the whole algorithm is the sum of the costs of each iteration. To simplify the description, that is, given the permutation of numbers from 1 to n, calculate the cost of Reversort. Let's take a look at some examples. Given 4, 2, 1, 3, start from the first position. From this position until the end, we find the mean value, which is 1. Then reverse this sublist. 4 to 1 to 1 to 4. The cost of this step is the length of the sublist, which is 3. Then we start from the second position. Find the mean value from this position until the end. It's also 2. Reverse this sublist. The cost is 1. Then start from the third position. Find the mean value. Reverse this list. The cost is 2. The total cost is 6. Given 2, 4, 5, 1, 3. Start from first position. Find the mean value. Reverse this sublist. The cost is 4. Then move to the second position. Find the mean value. Reverse the sublist. The cost is 3. Then move to the third position. Find the mean value. Reverse this sublist. The cost is also 3. Move to the fourth position. Find the mean value. Reverse this sublist. The cost is 2. The total cost is 12. The code is really simple. Just rewrite the pseudocode. So what is the time complexity for this code? For loop is O(n). Inside for loop, mean is O(n), index is O(n), slice is O(n), reverse is O(n). So the time complexity is O(n) square. Space complexity is O(n). N is up to 100. So this code is up to 10 power 4. T is up to 100. So this code is up to 10 power 6. This is the third problem, Reversort Engineering. You are given a size n and the cost c. Find a list of n distinct integers between 1 and n, such that the cost of applying Reversort to it is exactly c, or say that there is no such list. Let's talk about minimum and maximum cost. What kind of array has the minimum cost? The goal of Reversort is to sort the list. So, if the list has been sorted already, then it should cost the least. For example, given 1 to 6, the minimum cost is 1, 1, 1, 1, 1, 5, which is n minus 1. The minimum cost is n minus 1. What kind of list has the maximum cost? The kind that need to be reversed the most on every step. For example, this is the maximum cost. If the given cost is not in this range, then the answer is impossible. Now we can distribute the cost for each step. For example, given n as 5 and the cost as 12. Remember the minimum cost for each step is 1. Then distribute the maximum possible for each position. On each step, we know where to start reversing the sublist and the cost, which is the length of the sublist we need to reverse. so the problem is easy. We start from the position of the list, which is 0, 1, 2, 3, 4. And on each step, reverse according to the cost. Then we get the new list of the position. And after this reversing, the final list is supposed to be sorted 1, 2, 3, 4, 5. So just assign number to corresponding positions. The code is very similar to the first problem. I added the cost distribution and assigned numbers to each position in the end. The time complexity is also n squared. Space complexity is O(n). Thank you for watching.